So we'll take unit number 6 because 4 and 5 we don't have in the course. Okay, so we'll start with continue with the unit number 6 here. This unit talks about the structure of hardware and the software. So here we are going to talk about something hardware of the computer and the software. The aim of this unit is to draw a distinction between hardware and the software and firmware and describe the computer as a system. Functions of different components of a computer. What are the different components of a computer and their functions? Explore the way in which different parts of computer work together and to translate and execute the instructions given in a form of computer. Discuss some of the properties of different types of programming languages in which computer programs can written, and introduce you to ways in which computer programs can be structured and controlled, the order in which instructions the program are executed. This will give you first of all about the computer. What is the structure of computer? What is hardware? What is software? What is memory? Different types of memory. Okay. We'll talk about the software, different types of softwares. Then we'll talk about programming languages which are used to create the software. And then after that we'll start with the structure of a computer program, how it will be in general. After this unit, from unit number 7, we are going to take programs. We are going to take the programming language JavaScript, and we will learn how to write the programs. Okay, so this unit is important for you in terms of understanding the computer system and understanding how to write the programs and what is the structure of the program. So we'll start with the computer, hardware, software and computer system. Software, hardware and a firmware. Hardware consists of tangible parts of the computer system. Tangible, it means which you can touch and feel. So for example, monitor is a hardware that you can see, you can touch, you can feel it. Right? Hard disk is a hardware. Mouse, keyboard, these are hardwares. These are called tangible, which can be touched, parts that can be touched. This is called tangible things. Example, electronic circuit inside the casing, keyboard, motherboard, mouse, monitor, these are all the hardware. Software is more abstract and it consists of set of instructions that a computer perform a particular task, and these are intangible. You cannot touch a software, right? So this is called intangible, which you cannot touch it, you cannot feel it. So this is a software which consists of a set of instructions, some instructions to the machine, to the computer, to perform any task. For example, calculator is a software, and this calculator software to do some calculations like addition, subtraction, 23 plus 33. This is doing addition. Inside this software, what is there? A set of instructions written, some commands written to make these calculations. Okay, so any software is a set of, it consists of a set of instructions that tells a computer to perform a task. For example, word processor is a software, browser is a software, your WhatsApp is a software, Messenger is a software. These are all the software. The software and the computer programs are often used synonymously. It means sometimes we say software, sometimes we say program. Okay, they are used interchangeably. Okay. Although it is argued that software is generally a number of programs, it consists of number of programs, not a single program. Firmware is the term used to refer a sequence of instruction. It means stored or pushed, okay, into a read-only memory of the computer, usually perform some system functions. Firmware like BIOS, we have the BIOS, BIOS. When you start the computer, when you switch on the computer, first what it comes is the BIOS. You will get the black screen and some instructions there. That will start your operating system. So any program which will start the other programs, okay, these are the firmwares. Okay. So they are stored in a read-only memory, that is ROM. They are permanently stored in the memory. Okay, that you cannot erase it, you cannot delete it. Fine. Fine. A computer as a system, a computer is a device that accepts the data as an input, manipulate it, it means process the data, and give the output. And sometimes it will store the data. So take the data, process it, store the data, or give the output. Okay. So a computer has means of storing the input and the output and the programs, storing in the memory. Okay. So this is the general structure of a computer. The general structure of a computer, that there is an input, there is a storage, there is a processing, and there is an output. Fine. Input, output, and the instructions. The input to a computer starts of a word or a number entered from the keyboard. The input what will give. For example, this is a calculator program. Okay. What is the input? Is the number what we enter. This is the input. Okay. And the output is that when you press on equals to get you the output, the 59 what we are getting, this is the output for us. Okay. Processing is that adding the two numbers to get the result is called the processing. For example, now I said 2 plus 3. 2 plus 3 is the input. When I say press equals, yeah, the processing is done. 2 is added with 3. The output 5 is shown on the screen. Fine. So it can take other forms such as images, the input, the sound, or the digital information from scientific instruments. It can take input, can be of any form. Okay. Sometimes data will already available in the computer that can also be taken as an input via the mouse click or by some devices. Okay, you want to take the input from the file which is there in the computer. You open the file and take that input. Okay, sometimes which is also taken from the files which are stored inside the computers. For example, you want to edit a photo. What is the input for that? Photo is the input. Where is the photo? Photo is in the computer. You take that photo, that is the input to the Photoshop. So you open that photo in the Photoshop. So from where you are opening? From the computer. Okay, so the input is present in the computer in a form of file. You open that in a Photoshop, make the processing, whatever you want to make, change the color, add something, remove something. You save it, that is the output. And the output is also saved in the computer. Okay. In modern computers, all data including the instruction that make the computer program are stored in binary digits, that is in bits, that is zeros and ones. So anything in the computer is zeros and ones. In order to make the result readable by humans, the binary representation of the output need to be translated into the appropriate format. That we need to get back the output into the format what we understand. A computer has a CPU, that is the heart of the computer, central processing unit. A CPU consists of the three main things called ALU, arithmetic and logic unit, CU, control unit, and registers. The ALU is a component of the CPU, okay, that is central processing unit. CPU, it means central processing unit. So it is a component, ALU is a component of a computer which manipulates the binary data. that is doing calculations and all logical operations, adding, subtracting, editing the photo, all is done inside the ALU. CU is the component of that computer that coordinates the movement of data between ALU and other parts of the computer. It is control unit, it is controlling the instructions, what is coming, what is going, okay, all the registers. These are memory locations, small memory locations in which the recently used data is stored, and there is processing going on. You want the number that will be stored in the register. From the register it will take, the ALU will take, do the processing, and next number one from the register. So register is very fast, faster than the RAM. Okay, so register a small number of memory locations with both ALU and the control unit, which are used to hold single piece of data or a single instructions immediately before and after processing. Then CPU, it is the combination of ALU and the control units along with the registers. ALU plus control unit plus registered is the CPU, central processing unit. And this is defined, there is a main memory apart from the CPU, which is a larger memory area in which you can store the instructions, the programs which are needed by the CPU. So it is like you have the CPU. Inside the CPU there is a ALU, there is a CU control unit, and there are registers. And outside the CPU there is a main memory, what we call RAM. You see RAM of 2 GB, 4 GB, okay, that is outside the CPU. That will also have the programs which are executing by the CPU. So the CPU, the programs or the instructions come from the main memory, that is RAM, to the register, from the register to the CPU, to the ALU and the control unit. Fine. Now this CPU, called the processor of the PC, is a single micro chip which contains several tens of millions of circuits. Have you seen that microchip CPU inside the computer? Have you seen that? It is single chip. You will get like this. It is a square chip like this. Okay. If you want to see that, you can open the computer. If you see on the motherboard, it is fixed on the motherboard, which has the ALU and all. So it is a circuit. Okay, so like a microchip. Okay, which contains this circuits and all. There are many families of the CPUs. We have the Pentium family. Nowadays, what you have, the Pentium i9, right? i9 or i5, i7? I think i9. The processor. We don't know. The latest processor. He can tell us. What is the latest processor from Pentium for the computers? The latest processor. i7 or i9? You did not hear about i9. i7. You know i7. So let's say i7. These are families. We had i7, and before that we had i5, i3, and Pentium. We started from Pentium 1, Pentium 2, 3, 4. Then it started with i-core, right? Dual core. So it's all families. It's from Pentium. There is from Celeron, from AMD, Athlon. Okay. This family of processor has their own instruction set. That how they are going to process the data has their own instruction set. Every processor has their own set of the processing of the instruction, their own style of processing the instruction. Everyone is different from other.
Even i7 or i5?
Yeah, there has a difference. Okay. So this is the collection of basic instructions, called machine language instructions, which a particular processor understand. And the CPU, together with the way in which the memory, internal communication, and the input-output organized, defines the architecture of the computer. and it is firstly developed by a mathematician called John von Neumann. Here is the architecture of the computer given by this Neumann, okay, in 1940s. That it has some input device, and there is a main memory. There are the CPU. This is complete CPU, which has the ALU, arithmetic logical unit, control unit, and the register, and there is an output unit. So whatever the program or the input comes to the main memory, from the main memory it coordinates with the register, from the register to ALU, and the control unit will also take some instructions and will process this according to the instructions. More about this CPU and the memory. Control unit, it is responsible for interpreting the instructions into a computer program, send the appropriate control signals to the component that will carry out them. As soon as one instruction has been executed, the control unit moves to deal with the next instruction. It will process instruction by instruction. Okay. Once the program is started, there is no need for the user to interface. That is not there for us. Unit 4. This is Unit 6. Yeah. 4 and 5 we don't have. Okay. You have 6, 7 and 8. For the midterm up to 6. For the midterm exam it is up to Unit 6. 1, 2, 3, 6. Okay, and for the final exam 1, 2, 3, 6, 7, 8. 8 we just have part of 8, not complete. Fine. This is about the control unit. This is going to process the instruction. We'll take the instructions which are processing. Once the one instruction is processed, it will take the next instruction. Okay. Once the processing is started, the computer program start running, there is no need for the user to interfere into it, unless there is an input from the keyboard or there is a need of mouse click. If there is any outside interface needed, then the user will make it. Otherwise, the program keeps on running. Okay. A computer has different types of memory or a data storage. There is a main memory and there is a secondary memory. Main memory is used to store the programs which are going to execute near for current execution. For example, any program you open, that will first go to the main memory. From the main memory, it will go to the processor, that is to the CPU. So it is the main memory used to store a program of instruction and the data needed by the program while running the program. Its contents are volatile. Volatile contents, it means when you switch off the machine, when you off the machine, the contents will go. It will not remain. Okay. So volatile, they are lost when the computer is switched off. It is a volatile. The other is the secondary storage memory called file storage memory, which is, for example, hard disk or your flash or your CD, DVD. These are all secondary storage, and they are used to store the large amount of data, like in GBs. Okay, which can be used later. And it is a non-volatile memory. It means even if you switch off the computer, tomorrow you open on the computer, you will find the data which is in the hard disk. So that's why it is called non-volatile. Whereas volatile, it means that which is in the main memory. So when you power off, when you switch off the computer, the data will be lost, which is in the main memory. Main memory, how we can think of a main memory? We can think of a main memory as something like this, as a pigeonholes. We can think of a main memory as like this, that every block as a blocks. Okay, or it can have more blocks. If I have more blocks over here, and this is one block, this is another block, these are blocks. This is, we can think of a main memory is something like this. is divided into small blocks. Okay, so a main memory can be seen as a large collection of sequentially ordered pigeonholes. Pigeonholes is nothing but the blocks, okay, of which each can hold same number of bits equivalent to the word size of the computer. Word size of the computer is nothing but the bits, number of bits the computer can process in one time. So you have 32 bits or a 64 bit computer, right? 32 bits, it means that 4 bytes. So a computer can process 4 bytes of data in one time, in one instruction at one time. That computer can process 4 bytes of data, and in the memory, in one hole it can store 4 bytes of data if it is 32 bit computer, and if it is 64 bit computer, it can store 8 bytes of data. 64 divided by 8 is 8. So because 64 bits is equal to 8 bytes, so it can process 8 bytes of data. At the same time, it can store 8 bytes of data in the memory in one hole. Okay, so which one will be the faster one, 8 or 32 or 64? 64, because it is processing in one time, it will process 8 bytes of data.
One time, what do you mean by
one time? I mean in one fraction of second, for example. See, processing of data, it means that, for example, you have 16 bytes of data.
I get what you mean, but I mean the time it takes to, it's in the real time. How does it take to?
See, one is time in a at one time, processing 8 bytes at one time. It means that the time we can think of a fractions of second, because the processing is very fast. Okay, so we can think in fractions of second, or if we consider a slow processing, so we can say in 1 second it can process 8 bytes of data. But in reality is that processing is very fast. In fractions of second, at one time it will process, it can process 8 bytes of data. Okay. So here is an exercise. Suppose a computer is described as having 128 kilobyte of RAM. So how many bytes of memory does it have? And if it is 128 KB of RAM, how many bytes it is? Kilobyte. You have to convert the kilobyte into byte. How do you convert? 1 kilobyte is equal to 1024 bytes. So 128 kilobyte is 128 into 1024 bytes. Okay, because see, the memory unit goes like this. 1 byte is equal to 1 byte is 8 bits, right? And 1 kilobyte is 1024 bytes, kilobytes or bytes, and 1 megabyte 1024 kilobytes, and 1 gigabyte 1024 megabytes. So if you want to convert from kilobyte to byte, then what we have to do? Multiply by 1024. So you have 128 bytes, 128 kilobyte. Okay, then how many byte it is? It is 128 into 1024. So 1317072 bytes. Now if the word size of the processor is 64 bits, then how many words can the memory store? 64 bit is 8 bytes. So divide this number by 8 to get the number of words, that is 16,384. Okay. Then next, another exercise. Baby was a computer. The name of the early computer developed in Manchester. Baby has a word size of 32 and could store up to 8,192 words in the main memory. So how many bytes of memory are available? It is a 32 bit and it can store up to 8,192 words, and one word is 32 bits. So one word is how many bytes? 4 bytes. So if there are 8,192 words are there, so how many bytes? Multiply by 4. So you will get the bytes, that is 32,768 bytes of memory. Okay. So there was a computer with the size, with this size of main memory, that is RAM. Nowadays we talk about a RAM of 6 GB or yeah, the main memory is the RAM, right? Fine. Locations in the main memory are sequentially numbered. These locations in the main memory, they have the number, sequential number. For example, if this is 2021 and if it is 8 bytes, 2021 plus 8, so it will be 2029. 2029 plus 8, it is 2037, 35 or 37, and they are sequentially numbered one after the other. For example, this is your memory. Let's say this is the RAM, and the computer is of let's say this is the RAM and the computer is of 64 bit. 64 bit, it means 8 bytes. So every block is of 8 bytes, and every block has an address. Address is a number to access that block. So for example, this has a number of 2021. It is the address of this block, which is 8 bytes. Now after this, the next address will be 2021 plus 8, because it is 8 bytes, plus 8, it will be 2029, then 2037, then 2034, 45 plus 8, 45, and so on. So they are sequentially numbered. So that each one has a unique address, each one has a unique number, 2021, 2029, 2037, unique number that can be accessed directly. We can, if the number is known, we can access the data inside that memory directly. Okay. So this is why the memory is sometimes called as random access memory, because you can access that randomly. For example, you want the data over here, you go to this address and take the data. No need to go sequentially. You can go randomly and access the data. The memory address are numeric and starts with the location 0. So as a computer with n cells will have the memory address from 0 to n minus 1. So if there are 10 cells, from 0 to 9, 10 minus 1. If there are 20 cells, 0 to 19. 20 minus 1 is 19. So 0 to 19. The addressable nature of main memory makes the retrieval of data much faster than if there is need to search sequentially, because we are going randomly. Wherever we want, what the data we want, we go to the address, we'll take. So it is making more faster. If you go sequentially, you have to go one by one, which is a bit slow. So if you going randomly is more fast. Then we have the register. Register are very fast, efficient area of memory that are located in CPU and used as the holding area for data and other information which is needed during the processing of a program. Register, these are small memories inside the CPU. Main memory is outside the CPU, and registers are more faster than the RAM, and registers are more expensive than the RAM. If you are getting a 1 GB of RAM with 100 riyal, then registers you have to pay 1000 riyal. It's more costly, expensive than registers, because it is very fast in processing. It will give the data very fast. Okay. There are number of different types of register in the CPU. Some are located in ALU, some are in control unit and designed for to hold some particular type of information. Some register for holding numbers, some for holding characters, some for holding operators, plus minus, okay, different types of ALU is an arithmetic and logical unit. It can do all the arithmetic and the logical operations. Arithmetic and logical operations. It contains a number of registers to hold the data which they will process. It can do addition, subtraction, compare, add, subtract, multiply, divide. These are all the arithmetic operations. Logical operations, comparing. First number is less than second number is less than third number. This is logical operations. So these are all done by the ALU. Peripheral devices. Other devices which are connected with the computer apart from the main memory and the CPU, they are called the peripheral devices. Like you have the input output devices, monitor output device, keyboard input device, microphone input device, speakers output device. These are all the peripherals of the computers. Peripherals. So peripheral device is any computer device that is not part of the CPU and the main memory. So hard disk is also a peripheral device. Okay. So most common peripheral devices are input and output devices and the storage devices. Input devices like keyboard, mouse, scanner, microphone and all. Output devices like printer, monitor, speaker, and storage devices like hard disk, flash memory, or the CDs, DVDs and all. Okay. Some of the peripheral devices such as the hard disk and all, they are usually mounted along with the processor in the same case, right? You have seen that. And some of them will keep outside the computer, that is outside the case, that is the monitor, keyboard and all, but they have a connection. Nowadays you have a wireless connection also. PC also have a number of external ports, that is the connection points for the outside devices. Okay, that is the USB port. You have the USB port, the VGA port, the other ports you have to connect the external devices. The operating system. Now, till now what we discuss is the hardware part. We talk about the processor, CPU that has ALU, register, main memory. We talk about control unit in the CPU, main memory. We talk about hard disk, that external storage. We talk about the input output devices, keyboard. These are all the hardware thing. Okay. Now to run this hardware, to make use of this hardware, we need a software. Okay. So to run our computer, we need a software called an operating system. What is operating system? It means that which operates the computer. So we have briefly examined the hardware components of a computer, that is the processor, memory and the peripheral devices. Managing these resources to effectively coordinate and carry out all the tasks and the jobs, it is the job of the operating system. So common operating system we have seen, we have Windows, Linux, Unix, Mac. Okay. And for the mobile devices, operating system like Android, iOS, okay, Windows. So different operating system. So operating system is a complex piece of software that acts as an interface between the user and the computer hardware. Right? It is an interface for you. Through this, you can interact with the hardware. You can store the file in the hard disk. That is the hardware. So you want to store the file in the hard disk, you use the operating system, create the file, save the file, that will be saved in the hard disk. So you are going to use the hardware through the software, through the operating system. So it is why it is said it is the interface between the user and the computer hardware. Okay. It is going to do some complex task which is needed for you. The functions of operating system include provision of a user interface. It means it will give you the user interface to which you can interact, managing an allocation of memory, that the memory allocation and memory management, how to free the memory, how to allocate the memory, these things and all, controlling the peripheral devices, scheduling the access to the processor. For example, if 2-3 programs are running, so these are all processed inside the processor. So which program will take the processor for how many times, for how many seconds? For example, you play the video, you play the audio at the same time, you open the Microsoft Word, you play the presentation at the same time. 3-4 programs you play, you see all they are running, and you have only one processor. So how these all running with one processor? One processor can process one program, that is playing the video. But how this is happening is that through the management or the scheduling of the processor. Scheduling of the processor, what it will do? It will take all these 4 programs, it will give for first program 1 second. It will go and do 1 second. It will give, after 1 second, it will give chance to other. After the 1 second, it will give the chance to other. So the operating system will decide it. You have no interaction with that. You just open the programs and run it, but the operating system will decide it. Okay, this is called scheduling the access to the processor, then providing an interface between the computer and the application, and providing the basic utilities like disk formatting, file management, formatting the computer. These are all provided by the operating system. So how does computer know how to load the operating system? When you turn on the computer, how the computer will know that there is an operating system, I need to load the operating system? With the ROM, read-only memory. This ROM has a program called bootstrapping. So there is some instructions in the read-only memory ROM that will tell the computer to load the operating system. So that program, we call it as an boot program, and the process is called bootstrapping. So there is another type of memory called ROM installed in the chipset that contains a special program which is permanently stored in that ROM. Okay, this is a special program called BIOS. Okay, these program include boot program. Boot, it means start program needed to load the operating system when a computer lose power or switch on. When a computer switch on, so this program will come up and take the operating system to start. It will make the operating system to start. The boot program will typically run a test of main memory and see what peripherals are connected to the system before loading the larger program such as operating system. That's why when you switch on the computer, you see a black screen, and on the black screen you can see some instructions. In the older versions of the operating system, you can see the device names also. The hard disk of SATA hard disk connected, and this hard disk connected, this device connected. But nowadays you don't see that. There is some instructions for you. But if you press F1, you will get the BIOS. There you can see how many devices are connected, everything is there. Okay, so that it will make a run test to check what are the devices are connected, and then it will load the operating system, that program. So the process of using the short program to load the large program is called bootstrapping. Okay, so you might have a question in the exam, what is bootstrapping? It is a process of loading a larger program with the help of a short program. It's called a bootstrapping, or process of using a short program to load large program is a bootstrapping. The next is a cache memory. This cache memory sits between the main memory and the processor. We talk about registers, right? Register is inside the processor. This is inside the CPU, but this cache memory is outside the CPU, okay, but between the main memory RAM and the CPU there is a memory called cache memory. It will be like this. Let's say this is your processor CPU, which has registered ALU and CU. This is your RAM, okay. The cache memory comes between these two. Cache memory will have the frequent instructions which are going into the processor. It will take the instructions from the main memory, store in it, which are frequently used by the processor. So since the speed of the processor register exceeds that of main memory, because registers are more faster than main memory, so this potentially leading to situation where processing is slowed down due to wait for data to be delivered from the main memory. So there might be a delay. So to bridge this gap, we introduce a new memory called a cache memory, which is faster than the main memory but slower than the registers. Okay, cache memory fed from the main memory. It means it will take from the main memory before the data is finally moved to the register. So it means it will take the data from the main memory and give to the registers. And cache memory is more faster than the main memory. Okay. So some cache memories are now routinely for the midterm exam we have 4 units, unit 1, 2, 3 and 6, 4 units. Okay. So some cache memory is now routinely included on most processor microchips, and a typical PC have several hundred kilobytes of cache memory. Some cache memory, it comes on the motherboard. Then hierarchy of the speed and the cost. The speed of the memories and the cost. The higher the speed, it is more expensive. Low speed is low cost. Register are more faster, but they are high cost. Cache is above the register, main is above the cache, and hard disk above the main. Hard disk is more slower, but it is low cost. You can check in the market how it is, right? If you buy a hard disk of 500 GB, 500 GB, you may get for 200 Riyal. So for 200 Riyal, you cannot get a RAM, the main memory, for 500 GB. No. Okay, if you consider the RAM of 6 GB, 6 GB RAM is how much? 1000 Riyal or 1200 Riyal. I don't know exactly, but might be. But 6 GB of flash memory, 20 Riyal. So this is what it is. The low speed memory is low cost, and the high speed memory is high cost. Okay. Now this is all about the the computer, hardware and the software. So we understand the things what is related to the hardware, computer hardware, and the things related to the computer software. Now we are going to talk about the programming languages, and after that we are going to talk about the structure of the program, how the structure of the program generally, basically, without using any language. Okay. Then in the next unit we are going to start using the language JavaScript to learn the programming. Okay. Now here, types of programming languages. There are basically three types of programming language: low level language, machine language, and there is a high level language. This is high level language. Okay. Low level language are programming language in which each instruction is translated into a single machine language instruction. Every instruction, a program is what? It is a set of instructions to the computer. Okay. Every instruction is translated into one machine instruction. or you can consider every instruction is translated into 4 bytes of instruction if it is a 32-bit computer, which can be processed in one time. That type of language in which we write the instructions and that instruction is translated into one single instruction of the computer of 4 bytes or of 8 bytes, okay, that is called a low level language. A machine language is written using binary numbers, because machine understand binary numbers, zeros and ones. Any program, any language in which these the programs are written by using the binary numbers zeros and ones, that language is called as a machine language. So can you think of writing a program using zeros and ones? No. And it is very difficult for a human being to write the program in machine language. But what we write the program is finally converted into machine language, and after that it is processed inside the computer. What you have the software and all, when you run this software, it means they are converted into zeros and ones and they are executed. When you have the output on the screen, they are from zeros and ones, it is converted into what you see on the screen. Okay. So a machine language is a programming language written using the binary notation that a processor directly understands it. That is, a computer directly understands it. So also known as a machine code. Machine language is a low level language because every bit is in a one instruction. It's translated into one instruction. Machine language programs are purest kind of programs because the programmer is literally writing in the language of processor, that is in the language of zeros and ones, and there is no need of any translator because you are directly writing in zeros and ones. Okay, so a program working in the machine language can therefore exploit all the capabilities of the processor to the full, because he is writing the instructions in the machine language. He can use all the properties of the processor. However, there are many disadvantages of this machine language. Machine language programs are slow and difficult for the human to read and write. We can think of, can we do that, writing a program for zeros and ones? It's very difficult for us. Reading a program is very difficult. So memory references are given in actual location numbers. It means that you should know the memory addresses, because you have to put that also in the program, where you store the data, where you take the data, okay, all this. And each family processor understand its own machine language. Pentium understand its own machine language. Celeron, AMD, its own machine language. So it is difficult to have or to write programs and execute programs in machine language. The next comes the assembly language, which is also a low level language, but here it uses some instructions like add, subtract, SUB for subtract, for addition ADD, for multiplication MUL, for jumping instruction from one place to another JMP, jump, to start the instruction start, to stop the program stop. This kind of instruction which human being can understand. Okay, this is called assembly language. Assembly language. Still, this assembly language, there are assembly programmers, and there are courses on this. Courses on microprocessors. The microprocessor programs are written using the assembly language. Okay, there is a programming called MUP microprocessor 8085, 8086. These are programming languages, assembly languages, in which there are instructions like add, subtract, multiply, jump, store, locate, ALU, accumulator, okay, register. These are all the instructions, and these instructions are in the form of human understanding. Okay, so we have to study that this instruction is for this. Add for addition, sub for subtraction, mul for multiplication, jmp for jumping, start for start. Okay, this is this one. So this is a low level language, but computer will not understand this language. So what we have to do?
program to translate.
Yes, we should have a program to translate this assembly program into machine language, so that the machine can understand. So this machine language need to be translated by using some translators. So the task of whenever a program is written in a language other than the machine language, these the instructions in the original program are called source code. That is what we write the program using the assembly language. That is a source code, and we need to convert that into machine language, equivalent machine language. This task of converting the assembly program into the machine language, or the source code into the machine language, is called a translation. So when a source language is an assembly language, the program that does the translation is called assembler. So assembler is a program which take the assembly language program, that source code, and translate into the machine language. The next comes the high level language. Still this program, the assembly language, still we need to learn it. We need to understand the codes. Okay. The next level is the high level language. The high level language are the programming language which can easily understood by the human beings. The programming languages like Java, JavaScript, PHP, ASP, C, C#. These are all the high level programming languages which are written by using the English language, which can easily understood by the human beings. So high level language is a programming language which is written, which a single instruction might translate into several machine language instructions. Most programmers write the high level language because these languages are easy for human beings, and high level language instructions are closer to English and other languages, which leads to increase in programmer productivity. More programmers you will get. Due to increase in the readability, programs written in high level language are easy to debug and modify. Debug, it means to find the errors, any mistake in the program. It is easy to find it. Okay, because it is in English language, we can understand the things, we can understand the syntax, we can understand the rules, we can easily find the errors. Okay, so again, these languages, these programs written in these languages need to be translated into machine language, right? So we cannot have this high level language, the machine cannot understand, the computer will not execute. So this also be translated into the machine language. So there are two programs in which the high level language is converted into machine language. Those are compilation and interpretation. By compilation and by interpretation. Now what is compilation? In compilation, the whole program is translated into machine language in one time, and it will store the translated machine language program, that is the exe file, the executable file. You see the software, there is an exe file you will get, right? Executable file. This is a translated file into the machine language. You just execute that, click on that executable file, it will execute. It will start running, right? So it is the whole program translated into machine language. This process is called compilation. So compilation, programs written in the high level language, that is the source code, is used as the input and translate the program into, called a compiler. A translator program which takes which is called a compiler. The program which translates this is called a compiler. The compiler translates the source program into a program in machine language understood by the processor, and the machine version is saved. That is, for example, the exe file, and the machine language program is executed every time the program is run. So here the compilation languages are C, C++, Java. These are all the compilation languages. Any program you write in C, C++ or in Java, these are the compilation languages. When you run and execute, it will create an exe file. Okay, that file is run every time you run the program. Okay. Interpretation, this is a different mechanism. What in this will do, your high level program, it is a set of instructions, right? There is let's say there are 10 instructions, 10 lines in the program. In the interpreter, it will translate every line by line, and it will not store the copy. Compiler will translate the whole program and store the copy, save the copy after translation. Interpreter will translate line by line as required, and it will not save any copy. Every time you run, every time it will translate. So interpretation is a different mechanism for translating the high level into the machine language program. Translate each instruction in the source code into a machine language as the program running, and immediately execute it. You can think of line by line, it will execute it, and it will not store any copy. So every time you run, it will be translated every time. And languages such as JavaScript, PHP, Perl, Basics, these are all the interpretation languages. These are all the interpretation language. So what we learn, what we start, the JavaScript is also an interpretation language, which is executed line by line, and there is no exe file for you. After you execute this file, you don't find any exe file. Whereas if you do the program in Java, in other programming like C, C++, you will find that exe file. Okay, so when you take the course M150, okay, there you can, after you write the program in Java, you can check the executable file. Okay, fine. This is about the programming languages. So the programming languages, basically there are two types, the low level and the high level language. Low level languages, there are machine language and there is a assembly language. A high level language programs which are written in the user understandable way using the English. And to convert these high level language programs, there are compilations, there is a process of compilation and interpretation. So compilers are going to compile, that is do the compilation, that is converting the source code of the high level language into the machine code. Okay, difference between the compilation and the interpretation is that compilation will convert the whole program into the executable file and then execute and save it for the later, and interpretation will do line by line or instruction by instruction. It will execute, okay, and it will not save any executable file. Fine. That is about all about the programming languages. Fine. These are all the theory concept. The next we will see the structure of a computer program. So before we continue, it's all 8 o'clock now. Fine. So here I'll just stop here. We just have the structure of program. Fine. So we need one more extra class for this.